magnetic flux density, the magnetic field, the magnetic flux, including their units, something like that. And I'll also be differentiating between the magnetic permeability constant and the permittivity constant through space. Okay, something like that. So if you can remember, guys, this is very common in the gravitational electric force constant, right? EF is equals to K times Q times small q over R squared. Okay? This R here is the distance. For example, if you have two objects here, like this, one circle, big circle, like that. Ganun, di ba? So, this Q here is a small circle. The small q also. Let's say positive Q and big positive. This is the big Q also. Now, you take the centers of these two masses here, centroid, here, connect that there. This will be your R. Okay? So that is the distance between two centers of the masses. Now, your K here is the constant of electric force constant, 9.0 times 10 to the 9 Newton meter squared second squared. Like that. Now, take note mga palangga, this is also 8.99 by derivation, but they round off to 9. Because 0.99 is only 0.1 something na lang talaga siya. 9 minus 8.99 is equals to 0.01 something. It's very less difference already. It's 0.01. Just like we have in our acceleration due to gravity, which is a small letter g, and magnetic field strength. Not magnetic field strength, gravitational field strength. Okay? Value na to is 9.81 Newton per kilogram, the same as 9.81 meter per second squared. Now, some books also says 10 Newton per kilogram and 10 meter per second squared. It depends on the textbooks you are using. Now, if you try to subtract this difference, what is the difference? Time minus 9.81. So you have 0.19 difference. A little bit higher compared to this 0.01 here. So that's why I always use this 9.81 rather than this 10. Especially if I extract the choices, it's not really exact. There's a point something, because normally if you times that with the times 10, meaning the answer also will be exact because of the 0. Okay? So that's why I think I'll be using the 9.81 like that. Okay? So this 9.81 is common in different books all over the world in physics. Okay? Like that. So, now this one, the reverse for this one, the reverse means the unit of the reverse equals c squared, column squared over Newton meter squared. This is now your permittivity constant. This is still, yeah, permittivity constant through space. Like that. For example, there is a fill in the blanks question. Fill in the blanks question, and this only the value given. Then you try to recognize what's that. Your answer will be permittivity constant through space. This is your answer. Or reverse, permittivity constant through space. Pilay value sa kilid. Diba? Identification 1, 2, 3 until 100. And you need to identify by fill in the blanks the correct answer. So this is the purpose of theory. So you will master this kind of attack or approach in a type of a question known as identification. When there's a blank and you have to fill the answer and there's a description after that. Okay? So it looks like not very difficult because you only answer one term like that. It's not really explaining, which is an easy type of question. Easy type of question is the most intelligent question in an examination. It will test the totality of the comprehension of the individual. Okay? Not the multiple choice, not the true or false, like that, not the identification, not the define. Because the define, some examiners will only try to memorize literal, word for word. Okay? But in an essay, you have freedom how to phrase your sentence, how to phrase your paragraph, as long as you are getting the main point of what is being asked in that particular question. Okay? Something like that. So, this is the permittivity constant through space. The unit will be reverse of your electric force constant. What is the value for this? Okay, this is 8.55 times 10 to the negative 12. Coulomb squared, Newton meter squared. Okay, this one. Now, if I have here the K here, why did not use this K, this one? Because we need this one and we can derive this the formula also of K. So K is equals to 1 over 4 pi times this one, permittivity constant through space, and the symbol is epsilon. Epsilon is a Greek term in Greece that usually our previous scientists are using. Okay, for example, theta, epsilon, like that, rho, phi. Okay, and there's a lot, right? So that's the letters of the country Greece or Greek letters like that, blah blah blah. So we have the epsilon O. Okay, the epsilon O is just your permittivity constant through space. Okay, now if you try to substitute value of your K, the answer will be this 9 times 10 to the 9 Newton meter square second square, because as I told you, this is the reverse. Okay, let's prove that here and check again once more. So 4 times 3.1416, which is a pi. Memorize the pi. Pi is always 3.1416. Okay, times the permittivity constant through space, 8.55 times 10 to the negative 12. Now, if this is wrong, then my memorization fails. Okay, yeah, this 8.55 exponent to the negative 12 times 3.1416 times 4 is equal to blah 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 chuba chuchu. This is 1.0744 ang atong denominator. 10744 exponential to the 10, negative 10. And then you have the 1. Okay, divide this memory in 1 divided by 1.0744 exponent to the negative 10 is equals to, see, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9.1. Only difference also of 1. So the value is 9.1 times 10 to the 9 Newton meter square square. It's just equal here. Okay. Now, if you forgot this constant and you still remember the permittivity constant, then derive this equation. Right? So that you can have this K. But of course, you need to memorize this directly. Okay, so that no more hassle or no more burden in your part. But for the purpose of discussion, in case you will forget this constant, then you can still have another option, which is using the electric force constant is equal to 1 over 4 pi times the permittivity constant through space. Like that. So this one is not a magic. This came from this equation. Okay? Like that. Okay? It's very clear, right? Now I will teach you the difference between the magnetic permeability constant. Okay? This is enough. Okay? I have the magnetic permeability constant. So this is applicable in magnetic force now, because the permittivity constant through space is related to electric force. But this magnetic force talking about the magnetic permeability constant. And what is the value of your magnetic permeability constant? Okay, magnetic. But actually, if there's no word magnetic, that's understood to be the permeability constant of the magnetic force. Okay? Magnetic permeability constant. Okay? Like that. So it's gonna be 4 pi, okay, times 10 to the 7 Tesla. Diba? Tesla, okay, meter ampere. So this is unit, quite complicated your, unit. Be careful with the unit, okay? Because there's Tesla, at the same time there's also an ampere. It has to do something with electrical energy, okay? Or practical electricity topic, something like that. Because there's a word ampere. Okay? Muna siya ang magnetic permeability. Then how, and this symbol for this guys is, ano na siya? Mu. Mu also is a Greek term in the Greece. Mu. The same as theta, phi, epsilon, rho, ganon. So this is mu. Mu meaning 10 to the negative 6 or meaning micro. Okay, so forget about that as long as it is mu. Okay, mu. So this is your mu O. Oh, ganon. So through this, you have your mu O. You can use this in your equation of the magnetic field. Okay? Now, it is very surprising that our scientists in the past are using a very far letter for the symbol of magnetic field. Imagine they use the symbol letter capital B with the term magnetic field. Right? Supposedly, they will use the most nearest, let's say MF, so that the students can easily understand how MF, magnetic field. But they put capital letter B. Who cares that B? Right? So B in physics is magnetic field. Okay. Magnetic field formula is equal to the magnetic permeability constant mu O, this one, times the current in terms of ampere over the 2 pi d. The d is your length. Okay, the length of your material. Okay, something like that. Now, the length of your material is meter. The unit of your, mu O or magnetic permeability constant is Tesla meter ampere. And you have also the I here, the unit is ampere. Cancel the ampere, cancel the ampere, cancel the meter, cancel the meter. What's left is Tesla. So therefore, we conclude Tesla is the basic and standard unit of magnetic field. Magnetic field or magnetic flux density or magnetic flux alone. So we can say this is tantamount to the magnetic flux and magnetic flux density, which is equal to Newton meter per ampere, and then it's also kilogram, right? Second squared ampere, and then we will also say farad over meter. So these are all equivalent in units if you talk about the magnetic field. You get the point? It's gonna be like that. And that is the application of magnetic permeability constant versus the permittivity constant through space in electric force. Any questions so far? Nothing, right? Okay, so we need to forget this a little bit. We go to the magnetic field, which is common, okay, which is another formula, another version. Okay, we have also another version for this. Okay, capital B, okay, is equal to the current I, something like that. Okay, get the point. And then you have the force, okay, the force times the sine theta. Okay, again. Okay, magnetic force is equal to, okay, the B, magnetic field, the current, the length, sine theta. So Sotero, why sine theta? Again, let's draw this. This is the surface like this, and this is the y-axis, the positive, the negative, the negative, the positive, right? Okay. Then in trigonometry, we have 360 degrees is equal to 2 pi, right? So this is gonna be pi, then round, this will be 2 pi. So 2 pi is equal to 360 degrees. So therefore, this is the half, this is 180 degrees. So meaning to say, this is just pi over 180, right? Here, pi over 180. So, and your factor will be now the pi 180, like that. And then, so pi 100 over 80 times 360. So 1, cancel 2. That's why 2 pi ang 360. Now, ang 180 times pi over 180 cancel. So your half here, your 180 degrees is also your pi. Okay, pi. Okay, 180 degrees equivalent to pi. That's why we say 2 pi because 180 plus 180 is equal to 2 pi. Like that. Okay, so that's why we have circumference 2 pi because that is the complete round of the pipeline. Okay, the outlet and the inlet. Okay, so that's why we have 2 pi r, the radius, which is the circumference of your circle. Ganon. So here, how can you compute here? Hanap na nimo. So it's going to be pi 180 90 degrees, kaya katuma naman siya. So, 90. So, pi 90, 180, chuba, chuchu. Ganon. So, 180 divided by 2. Ganon. Okay? So, ganon lang siya mga palangga. 1 pi 180 yun yung kuan. So, muna siya may tabo. So, this is here. Tada! Ganon. So, 90 degrees. Okay? 90 degrees, 90 degrees, 90 degrees. Di ba? Okay, right triangle man siya, 90 degrees. Di ba? So, ito pang katunga, 45, 45 degrees, 45 degrees, 90 degrees. So, 90 degrees times pi 180. So, cancel. So, pi over 2. So, therefore, your 90 degrees is also pi over 2 or 1/2 pi. Okay, now you go here. So, this 90, okay, 90, 90, 180 plus 90. This is 270. How can you call there? So, 270 na po. So, 270 degrees times pi over 180. So, cancel. That's chuchu. Okay, so pila ba na siya? Okay, so 270 divided by 180. Ganun, chuchu. Okay, 60. 180 divided by 90 is equals to 2. So, this is 2 pi and then 270 divided by 90. I think 3, right? So, this 3. So, meaning to say this is 3/2 pi. So, your 270 degrees here is 3/2 pi. Okay. Now, you can use this pi, chuba, chucho in a radian computation in the calculator. So we have your scientific calculator, you have the mode here. You can press the mode 5, I think. Mode 4 is degree, mode 5 is radian to convert the conversion of radian to pi, radian to degree, degree to radian. Okay, especially for example, angular acceleration, angular momentum, rotational moment of inertia. Mga ganon. Di ba? Centripetal force. Okay. Angular velocity, meaning radian per second. Okay. Angular acceleration, meaning radian per second squared. You will just replace the meter with the unit radian to emphasize that that is really a pi radian degree of measure in trigonometry. Okay, this is very basic. Okay, and the problem also sometimes will indulge or will engage like this. For example, volume of a sphere. The volume of a sphere having a 2 pi blah 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 so and so. What is the volume in terms of pi? Only asking the variable, not really the figure. There's also a problem like that. The answer will be 3.8 pi. Like that. Then you can also convert the 5, 3, 14, 16. You can multiply that one to have the figure. But the choices in the exam is no direct. Always 2.5 pi, A, B, 7.1 pi, C, 1.8 pi. Okay, ay pugsa kayo. The choices having a pi na sa kilid. Okay, ganon. Okay, so any questions so far? Ano masayang theta man siya? Why? Okay, going back to the work. Work is equals to force times distance, right? Okay. And then your distance is here, as I told you. Right? Your distance is here. As you go here, guys, in the initial point, mga palangga, ang hitad. Okay? This is 0 degree here. Okay? 0 degree. If you have the 0 degree, okay, like this, blah, 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 so on, so. Let's say, okay? So, ang sa kaman mo, so sine of 0 degree, pila lang siya. Okay, 0 sine. Sine 0. So, is equals to 0, right? And sine of 180, pila siya. Sine 180, 0. Okay, now, sine is 0. Okay, like that. You get the point? So if you multiply something to 0, it will become automatically 0. So cosine theta. So cosine 0, 1. Okay, cosine theta is 1. Okay. 1. Then cosine of 180 degrees is negative 1. Okay? Like that. So cosine of 0 degree is 1. That's why in your work equation, you will never put sine theta beside the d. Because the cosine theta here is understood to be 1. You get the point? If you base the angle of inclination. So that will become works is equals to force distance. If you are just doing the horizontal pushing of the object, then there's no angle of inclination. Then 0. Then cosine 0 is equals to 1. Then 1 times this is equal to d. That's why work is equals to force times distance. Okay? Muna siya. Okay, but if there is an angle of inclination, mapugos nagbutang diri ari nga mga chuba-chucho, d cosine 20 degrees, d force times d sine degree. If there's an angle of inclination, okay? Especially if you pull, attention force must be there, ganon-ganon, di ba? Nakakaloka. Okay? Ana na siya guys, mga palangga kong hitad. Okay? Any questions so far for this topic? Okay, nothing, right? Okay. Any question mga palangga? Di ba sa'yo pagamay? Charot. Okay. So, any questions so far? So, na-solve na natin. We already solved 3 problems. 4 problems ba? Okay. Like this. Yes. Okay. Yes. We will solve 4 problems na siya. Okay. Ganon. So, I hope you like this video and you can click down the notification bell top. Okay? You want to subscribe my channel, then you can share, you can like, and you can also click the notification bell for some viewers after the message and voice. Bye bye, God bless everybody. Remember that Jesus loves you and me. Jesus loves us. Thank you. Bye bye. God bless.